Atoms can receive electrons, making them negatively charged, like how a sulfur atom becomes a sulfide anion with a charge of 2-. Meanwhile, atoms can release electrons, leaving behind the positive charges by protons, like how an aluminum atom becomes an aluminum cation with a charge of 3+. To get the formula of the compound they'll form, we can cross the charges like this, giving us Al2S3, aluminum sulfide. Having 2 aluminum cations give them a total charge of 6+, and having 3 sulfide anions give them a total charge of 6-. By having this specific number of aluminum and sulfur atoms, the number of positive and negative charges are equal. In determining the formulas of ionic compounds, we must be familiar with how the charges of atoms are related to their placement on the periodic table. Also, we must be aware that transition metals may have more than one known charge as summarized by this table. We must also be familiar with polyatomic ions, or ions that are composed of more than one atom. To get the formula of magnesium fluoride, we need to get the common charges of magnesium and fluorine from the periodic table. Their common charges are 2+ and 1- respectively. By crossing their charges, we get the formula Mg1F2, but we don't really write ones anymore, so MgF2 is fine. To get the formula of ferric oxide, we need to get the charge of the ferric cation from the table of transition metal cations. Oxygen's charge, on the other hand, may be taken from the periodic table. By crossing their charges, we get the formula Fe2O3. To get the formula of aluminum sulfate, we need to get the charge of the sulfate anion from the table of polyatomic ions. Aluminum's charge, on the other hand, may be taken from the periodic table. By crossing their charges, aluminum gets a subscript of 2. Sulfate gets a subscript of 3, but in order for all of its atoms to get the subscript, we write SO4 with brackets like this. Book your free demo session now!